basic point we learnt about TypeScript yesterday, that TypeScript is completely built with TypeScript. Means it doesn't need any another language support for even interacting with operating system. To interact with operating system also, it doesn't need any separate support. It can directly talk to operating system service. So what it contains, how it works, let's see. So the basic TypeScript architecture. So this is the TypeScript architecture. This is the TypeScript architecture. What actually TypeScript contains. These are all the components of TypeScript. So what are these? How they work? We will see. What are the points and how they work. Already basic introduction I told you yesterday. So this is Anders Hazelberg. This is the person architect of two languages, C# and TypeScript. Because if anywhere outside you see, you have to say hello. Na? That's the reason I am showing his photo. Huh? So this is Anders Hazelberg, and he is well known for the famous OOP language, C# and TypeScript. And this evolution internally happened so many years back. We don't need all of that. So, but the basic architecture is important for you. How TypeScript works, what is the basic infrastructure. Let's see. Actually, at the bottom, you can see TypeScript is having a core compiler. You can see TypeScript is having a core compiler. So this is the TypeScript core compiler. What is the purpose of compiler? You know, compiler purpose is identifying the syntaxes, verifying the code blocks, managing conversion of data types, input, output, all these are managed by this compiler. Actually, you can see in the compiler, it is having some files. We have core.ts. There is a core.ts file here. Program, scanner, parser, checker, emitter. Actually, in your general programming languages also you have them. Usually, because those languages you don't learn what is inside compiler. But do you know what is the job of scanner? Any idea? If you learnt any programming language, scanner is responsible for input. In a programming language, input activities are managed by using scanner. That's the reason you might have seen C programming have scanf. Why input is called scanf? Because scanner is a compiler component which is responsible for input. So scanner is responsible for input. Emitter is responsible for output. Output is managed by emitter. So we have a scanner for input, emitter for output. Checker is for data type checking. That means it is verifying the data types. What type of data you initialized, what type of data you are storing. Conversion of one type into another type is done by parser. And Program TS is responsible for verifying the syntaxes and code blocks. That means, is your syntax according to the requirement? Is the code block started? Is it ending properly or not? The flow of execution, everything will be verified by program. Core.ts is responsible for loading all the basic library required for your program. That means initializing your program, loading the files that are required for your program. These are all done by using core.ts. So inside the core compiler, these all are the concepts available. So TypeScript have a core compiler. What is the job of core compiler? Verifying the code and compiling the code and verifying the issues, reporting the issues. If any issue is present, it is not going to run your program. The compiler will stop. We have another compiler. You see, there is a standalone compiler. So why we have two compilers? There is another compiler, standalone compiler. Why you have two compilers? Because the language TypeScript is not understandable to browser. Browser understands JavaScript. So TypeScript is translated into JavaScript by this compiler. If you are using only TypeScript, you don't need this. If you have to convert TypeScript into JavaScript, then you need a trans compiler, TSC. That is a trans compiler. That means you have a TypeScript standalone trans compiler, which is responsible for converting the TypeScript code into JavaScript. After successfully compiling, it will convert the code into JavaScript. So you have two compilers. One is core compiler, another one standalone. Okay. Understood now? Right. Now we have a language service. Now the question is, what is the purpose of a service? You already learned. We already discussed in React. In hooks, I told you what is a service factory. Remember that? That means service is a predefined business logic. Service is a collection of factories. Factory is a collection of functions and values. And you see, language service means whatever TypeScript requires, the library for TypeScript is present here. Language service provides all the functions and values that are used by TypeScript. TypeScript have to use ready-made functions and values, so all they are present in language service. Language service provides all the functions and the factories that are required for language. They are going to provide all of them. And you can see there is a TS server. So what is the purpose of server? Generally tell me, what is the purpose of a server? Server's responsibility is to host your application, handle the request and send the response. What a server does, it will host your application, handle the request and response. TypeScript application, TypeScript programs are translated, compiled and interacted on TypeScript server. TypeScript have its own server. Generally, other technologies need help of another server. They have to use other servers, but TypeScript have its own server. It can host the application, it can handle request, and it can send a response. So TypeScript server is responsible for hosting application, handling request and response. We have a VS shim. Actually, shim is very common. If you are learning any OOP language, object-oriented programming, shimmers are very common. Java shim library, .NET shim library, C++ shim libraries will be there. Because you might have not learnt about them because your level is not up to that. Your level is just only basic programming. So you might never heard about shimmers. So that's not your problem because you don't need to know about it. So you don't know about shimmers because you don't need them. So your level of learning of technology is not required with knowing about shimmers. Actually, that is required for people in architect level who are responsible for building libraries. They know about these shimmers. Actually, shims is a library which is available in every OOP language. And not only OOP languages, shim is responsible for what is the concept of shim. Actually, it is taken from the word shrimps. You know, the seafood like uh, prawns, prawns and shrimps are present. Shrimp and prawn, two are present. Shrimp and prawn. Just basic, actually, the word is taken from there. That's the reason you need to know a little bit about that. So here, suppose you see prawn versus shrimp, you can see these are two prawn and shrimp. These are two prawn and shrimp actually. So image wise, they means picture is image is there. So image itself is here, right? Okay, just basic image I am showing here. You can see this image. Just I will zoom it a little bit now. You can see this is the images. You can see both look similar now. But actually, do you know the difference? You know, shrimp is gender neutral. It is gender neutral. That means it is neither male or female. They are gender neutral. Shrimps are gender neutral. So why the word shim in your programming languages? Actually, if you search here, Java shims library, you have a Java shim library. Java have a shim library. Shim library is present. Java shim library, C sharp shim library. You will have a C sharp shim library. It is a shim library. They have shims library. So you may not learnt about them because you don't need them. But do you know what is the meaning of the word shim? Shim's library means actually shim makes your language platform neutral. Your Java claims that it is platform independent. That is because of shim. Right? .NET claims that it is platform independent. How it makes platform independent? That is because of shims. Shim is a very small library, so you will never use it. Of course, I told you now, you might have never worked with reflection API. You worked? It's very good if you have worked with reflection APIs. What is reflection API? Reflection API is the concept of understanding the properties and methods of any library. That means when a class is provided to a developer, he can track the properties, methods, and their type by using an API called reflection. That is very important at real-time environment level for a developer to know about it. Similarly, shims also important. What is the concept of shim? Shim is a small library which is responsible for making your language platform neutral. That means if your language claims that it is platform neutral, that is because of shims. So it is neutral. That means it makes it understandable to any operating system service. And for that, it uses a managed language service. You have managed language and language service. What is difference between these two? Actually, why these words are maybe new for a Java people, but not new for Microsoft people, because TypeScript is a Microsoft language. And Microsoft people already knows the point about managed service and unmanaged service. They know it. Microsoft people already know about managed language services and unmanaged language services. For Java people, it may be new because they may be new to this, but Microsoft people have an awareness of this. That is nothing but language service is platform dependent, managed language service is platform independent. A managed language service is platform independent. That means it can run on any operating system service. Shims will generate a unmanaged code, managed code. Two will be there. Before Shim, it is managed code. It is unmanaged code. After Shim, it is managed. Managed code is the code which is understandable to every operating system. Actually, so you don't need this on. Okay, I will show you Visual Studio Code. Right. So, yeah. Actually, this is the managed library. This is the, yeah. This is how actually Microsoft languages usually work. That's how they work. That means generally you write the code that it is translated by the compilers. When it is translated by compiler, it will be a managed code. Managed code is the code which is platform dependent. This is a unmanaged code. First, directly compiler will get unmanaged code. Unmanaged code is platform dependent, operating system dependent. On which operating system it compiled, it will work only for that operating system. Now, what your technologies like Java and other do means here, because TypeScript is a Microsoft language, what it does, it will take help of compiler. It will generate an assembly code, intermediate language code. It will generate the unmanaged into which one managed. It will use another compiling system inside. By using that, it will generate the code into native. Native code means it is understandable to every operating system. It is cross-platform. This is normal nature of Microsoft languages. And the TypeScript is also same following. TypeScript also a Microsoft language, so it follows the similar architecture. So that is the reason you have two services. One is language service, another one is what? Managed language service. Language and managed language service. So why you have two? That is because of this. So I hope you understood all the points. So in the TypeScript architecture, we have core compiler, we have a standalone compiler, language service, managed language service, shimmers, and server. Editor is nothing but it is just to tell that it supports all editors. That means this language can run and support on any editor. You learned in the beginning itself various editors are there. Which editor we are using? Visual Studio Code. We can use in any editor. Any editor can use it. So the basic architecture of TypeScript is this. And if you have observed important, every file is a TypeScript file. Server is created in TypeScript. Compiler is designed in TypeScript. You see TS files now? .ts files. That means they are created in TypeScript. They are native for operating system. Majority Microsoft technology languages means they build for their operating systems, but these are platform independent. They can run on every device, right? So this is the basic infrastructure of TypeScript, right? What TypeScript actually contains. Let's keep one point here. I'll give a simple overview about that. First, what it contains. Core compiler. TypeScript have a core compiler. TypeScript core compiler. So it is responsible for translating the TypeScript code into OS native. It is responsible for translating the TypeScript code into OS native, operating system native. So it identifies the issues in code and reports as errors and reports as errors. Compiler manages various interactions through different components. So we have core.ts loads the core library required for program. Program.ts checks the code blocks and execution flow. So we have scanner.ts responsible for handling input. Emitter.ts responsible for handling output. Checker.ts verifies the data types. Parser.ts responsible for converting one type to another. And not only these, there are so many things. These are few major in compiling. Usually every compiler have like that, but you will not learn about that because explaining a compiler is not required, right? Just explaining compiling process is enough for you. So any programming language, when you learn, they will tell you that there is a compiler which will do that. But there, we have a topic of understanding what is inside compiler and what they does, how the actual program is translated. Everything we can understand, but it's not required. So TypeScript level, if you know, that's good. This is core compiler. And we have another one, standalone TS compiler. Standalone TS compiler. Standalone TS compiler. So it is a trans compiler responsible for translating TypeScript code into JavaScript. tsc.ts handles transcompiling. Handles transcompiling. tsc.ts. It is responsible for handling transcompiling. Next, we have a language service. You know, basic service is a predefined business logic. It is a set of factories and factories with functions and values required for application, required for TypeScript program. You can say application. So services.ts. Services.ts handles library. It handles library. But what is one more point about it? It is OS. It is OS relative library. It is OS relative library. Operating system relative library. It is not a library understandable to every operating system. Which one is understandable to every operating system? Managed language service. So it is, managed code. Managed code is the code understandable to every operating system service. Is the code understandable to every operating system service? So it makes the code OS neutral. It makes the code OS neutral. Sorry, it makes the library OS neutral. The code OS neutral is done by shims. Shims, actually it is in shims library. Shim is a library used to make platform independent services, is to make platform independent services. It is responsible for converting the unmanaged code into managed code. the unmanaged code into managed code. So who manages that? shims.ts. shims.ts manages all shims.ts manages all interactions on unmanaged code. So these are all the components. Server, TS server. TypeScript provides a native server to host application to host application. So it handles requests and response. It can process the application in processing pipeline. So this is all TS server can do. Server.ts handles the server. So that's what it does. So that is TypeScript server. That is basic infrastructure. What actually TypeScript comprises of, how it actually works. Generally, it is not the primary language for React people. This much depth about TypeScript is required if you are learning Angular, because for Angular, TypeScript is primary. They don't use JavaScript. So, but what we are discussing in TypeScript here in these sessions, that is enough to handle even Angular. In future, if you are learning Angular, this TypeScript knowledge is more than enough to deal with the Angular like frameworks, right? Actually, there you cannot directly start Angular. If you are learning Angular, first you have to learn TypeScript, then you have to go to Angular because it's a new language for you. There also, these basics of TypeScript are same. Everything is same. So now, after understanding, we are not building a React project now. First, we will learn how to build a TypeScript project. We will learn the language. Then we will use that language in our React. It is very easy and simple, fast for us, because for people who know JavaScript, TypeScript is same, easy, very fast and easy. Only some additional new concepts they have to know. Those we will take slowly, we will understand about them. So let's see how to set up TypeScript project. Set up TypeScript. So you have to set up TypeScript and create project, TypeScript project. Set up TypeScript and create TypeScript project. You have to see how to do this. Let's see. First step, what you have to do, TypeScript is not default available on your computers. You have to install it. So how do you install TypeScript is open your command prompt or terminal. Command prompt in Windows, terminal in Mac or anywhere you have a shell. So there you have to run the command. So npm install globally TypeScript. That's what you have to run. npm install globally TypeScript. You have to run this. So why globally? Because if you don't use global flag, it will install in the drive where you executed it, and it will work for projects in the same drive. That means you have to make sure that all your projects are kept in the same folder. But now you can put your project in any folder on your PC, any location you can keep it. After that, you check the version of TypeScript. Check the version of TypeScript from the terminal tsc-v. What is this TSC? TypeScript compiler, transcompiler? Just now you saw na tsc.ts. It is the TypeScript transcompiler. That is TypeScript compiler version. Right. So you can see this is my terminal, and I have already installed TypeScript on my terminal. So here tsc-v, it will get the version of TypeScript. Current version of TypeScript is 5.9. So npm install globally TypeScript. Okay, let's check the latest version, 5.9.3, same. There is no change. So I have the latest version here. But your React Angular projects are not using it. They use 4 version. Maximum they use 4 version, because every latest version is not updated by companies immediately. They will wait and migrate only when they need it. Right? They are still using TypeScript 4 version in projects, majority Angular and React applications. Latest is 5.9, right? Now, remember, I told you already, we can learn TypeScript as a language individually to build apps, but that's not our target here. We have to learn TypeScript for web. What TypeScript is required for web technologies, especially for front end, only that part we are learning. We will not say that I know TypeScript. We will say that we know TypeScript for Angular and React, because it is individually a huge language. So much is there. So same like your Java or C# like programming languages. It has so many things internally. So initially your application means your PC is ready with TypeScript. Now what you do after that, just create a project temporarily. How do we create a project? So what you need to do is create a new folder for TypeScript project. So any location in your PC, you create a folder. Suppose if it is your Windows, you create some C drive, D drive, anywhere, TS project, something, any name you can give. Then open in Visual Studio Code. So then run the following commands in terminal, in project terminal. In project terminal, you have to run the commands. So one command is same. Actually, here you see, we will open the project location. Yeah. So I have documents, class projects. Okay. I will create a new folder, TS project. Okay. Let's open in Visual Studio Code. So I'm opening the folder, and that is TS project. It's an empty one as of now. And here open the terminal, and this is your terminal. Already you are using terminal. So here what you have to do is, in the terminal, you need to run the command. You need to run the command tsc. First we will use npm init y. You know this now. It will generate package JSON. So package JSON is ready. We need another one is tsc init. This is TypeScript initialization, tsc hyphen init. Yeah, this is TypeScript initialization. I think this is my terminal where I cannot run. I have to change my terminal because I have multiple terminals. Okay, here it tsc init. So this is tsc hyphen init. It is TypeScript initialization. It will generate a file called tsconfig.json. Two initializations you have to do. One initialization is npm init flag y. Another one is tsc hyphen init. These two commands you have to run. What this is going to do, generates package.json. This generates tsconfig.json. Actually, in older version of TypeScript, it used to generate two files. But now in latest version, it optimized both files logic into one. If you see old projects designed with the TypeScript language, you will you will find one another file called tslint.json. tslint, that is TypeScript language analysis tool. But they have removed that now in latest versions, and they have optimized both logics into one file. What is this tsconfig is? TypeScript configuration for your project. What is TypeScript configuration for project is nothing but you are saying that TypeScript code is translated into JavaScript. Am I right? Yes, na? Right. So into which version of JavaScript? TypeScript current version is 5.9. It will translate code into JavaScript. Which version? That we will decide here. That we will decide here. TypeScript is going to use a modular system. I told you modular system, CommonJS, RequireJS, and I. So which module system to use, we will decide here. What are the TypeScript language rules? Are there any restrictions? We will put rules also here. So this actually earlier we used to have rules file separate, configuration file separate, but now it is optimized into one. So 4-5 years back, if you see projects designed with TypeScript, you will find two files in them, tslint.json, tsconfig.json, but now you will find only tsconfig. So just a simple note I will give here. So tsconfig.json is a TypeScript configuration and language analytic tool. language analysis tool. TypeScript configuration and language analysis tool. So early versions use two files. So one is tslint.json, another one is tsconfig.json. Right. So you can see not only that, in that so much is there. It comprises of information about where to save your output files. Output files means JavaScript files. Later, when you use TypeScript for React, you will see lot of configuration is added, right? You see it is generated now. And once it is generated, you can see tsconfig JSON. It has a lot of things. And so many points are commented because we enable them and we add more rules according to requirements. Later, when you are adding more features into project, this file will be updating. It will be adding with new features and setting up. You see, it says that root directory is .src, means you have to create a folder src and keep all the files, dynamic files. Dist folder is nothing but production file, production folder. Production related all files are present in dist. That is that file. It is showing module. It is using node module system. Node have a next module system. It is using node next module system. But that means it is using a node compiler to compile. We have to use node. You can use ES module. You can use CommonJS, CJS, UMD, AMD. Remember in the beginning, I told you how to install React individually in a separate web application. There we learned about this. It will show all these options. So many rules we can enable, disable, right? So as of now, you don't need all this. Just later you can update them according to your projects, right? So this is the tsconfig file. Okay, now just we are using TypeScript as a language. We will not link with any UI. We will learn TypeScript as language. So what we will do, just we will add one new file. The file name we will give index.ts. TypeScript files must have extension .ts. Okay, in this you can write the TypeScript code. And remember, TypeScript is almost everything of same JavaScript, but it is strictly typed, strongly typed. It is strict and strongly typed. What changes are there, I will explain. But initially, first basic program. Remember, you are using TypeScript in browser, means you are using TypeScript to target browser, then you write DOM methods. Otherwise, never use DOM methods. DOM methods means what? Alert, document dot write, confirm. So those will not work here. Why we will not work? Because those you can write if you are targeting this TypeScript to browser. As of now, we are not targeting to browser. We are just testing here. So we will just put simple console log methods and we will say welcome to what? TypeScript. After that, this is just a output. We haven't learned anything about TypeScript, just a basic output I am showing. Now this line of code need to be compiled into which one? JavaScript. So what you have to do? You have to just open the terminal and you open the terminal and compile this TypeScript file. You have to compile by using tsc index.ts. When you compile, what is tsc? Just now you saw it is a transcompiler. It is a transcompiler. It will transcompile this into JavaScript. When I hit enter, it is going to generate JavaScript file here. Acha, my terminal is different. Huh? Okay, I will use this because I have multiple terminals. So TSC, what is it? Index dot what? TS. And it is transcompiled and a JavaScript file is created. You can see it will add a JavaScript file index.js. Now in this index.js, the code is translated. I told you, you will not find any difference now because it is nothing, just a console method. Later, when you write complex program in TypeScript, it will not translate and show everything to you. It will translate and show only what is required for output. Only required for output. So many things it will hide, it will not show you. So anyhow, once JavaScript is created, if you want, you can link this to HTML page. Otherwise, you can compile in the terminal itself and check it. How to compile? You have to use a node compiler. Node compiler, what is the file? Index.js. JavaScript files are compiled using a node compiler and it will show the output. Welcome to TypeScript. That is just the console method we are using. If you are using alert or document write or something else related to DOM, it will show error because it says that alert, document write, confirm all are window methods now. So they need to be executed inside a browser only. If you run outside browser in command line, how they work? They can't work. So make sure that you are using only the basic which is required for command line. Okay. So what is the process you need to do here is one more point, add a new file. So add a new file into project index.ts. Index.ts. So with some code console.log some welcome to TypeScript. After that, what you do? So TS with following code. After that, compile from terminal. Compile from terminal. What we have to do? So we have to use TSC index dot what TS. And remember, just like you done in your Java or other programming languages, whenever you modify the code, every time you have to compile again and you have to run, right? So after this, after compiling, you have to, what happens here? Generates index.js. So run index.js with node compiler. So we have to just use node index.js. With node compiler. This is the basic. Now what we will do in this, we will see how to means what are the differences now. So we are going to learn here TypeScript language. We are going to see the language. Variables, data types, operators, statements, functions, are OOP concepts. Are there any changes? If there are changes, those changes only we will learn. We will not learn all the points. I will not explain what is var, let, const and all these now. We'll just see, is there any change? What is that change? That we'll see tomorrow. Right, in tomorrow's session, we will start learning all the complete language basic of TypeScript. Before that, you set this and try. Then tomorrow we'll continue. Okay, right.